Do you want to see how the universe began? Then contact the Brookhaven Science Laboratory in New York. In 2005, they recreated a very hot thing: quark-gluon plasma. This is the state of elementary particles, quarks and gluons, which were formed after the Big Bang. The plasma temperature is about 4 billion degrees Celsius, or 39 billion degrees Fahrenheit. It's 250 times hotter than the solar core. It's a pity that scientists watch this plasma in a closed laboratory without a live broadcast. But luckily, you have Riddle, which, for the sake of hot shows, will go further than the scientists from Brookhaven. To space. We'll take there the scorching sun and pour 1 gallon of extremely cold liquid nitrogen on it. How will these two substances interact with radically different temperatures? And what consequences await humanity as a result of such a hot experiment? We won't delay with the answer. Here's the sun, here is a gallon of nitrogen, here are your sunglasses so that you don't get freckles from the sunlight. Ready? Pour. We're waiting for the reaction. Still waiting. But there won't be a spectacle, at least for now. After all, nitrogen, either 1 gallon or 100 gallons, won't even reach the sun. Our star's temperature is around 5,505 degrees Celsius. That's 9,940 Fahrenheit. Such heat is simply unbearable for liquid nitrogen. It will expand to a gaseous state and evaporate in space. But we're not going to give up so easily, right? In the end, we gathered here for the spectacle, and we get it. But how to fix the problem and make the nitrogen touch the sun? Maybe we could immediately send this cold element deeper. For example, straight into the solar core. We know that at high temperatures, liquid nitrogen turns into a gas. But if already at the beginning of the experiment this element will be in the core, we'll definitely have time to see its interaction with the sun. After all, to break out, nitrogen gas will need to fly through the entire atmosphere of the hot star, and this as many as 3 layers: the photosphere, the chromosphere, and the solar corona. That is, our chances of seeing at least some reaction between the sun and nitrogen increase greatly. But before continuing, you should know the risks of such an event. After all, scientists believe that this experiment with nitrogen in the solar core could destroy the entire solar system, including us, the inhabitants of planet Earth. There's irony in the fact that nitrogen can provoke the death of all life. After all, this element is often used in extinguishing fires. Not all, of course, but only those that arise in enclosed spaces. For example, in mines, nitrogen, unlike oxygen, doesn't support combustion, and at the same time extinguishes fire more accurately than water. Keeps intact everything that is in the fire zone. It would seem that this feature element deserves some cool nickname, perhaps Captain Nitrogen. But scientists, and in particular French chemist Antoine Lavoisier, for the very low temperature of nitrogen in the liquid state, called it simply azote, which means lifeless. If Lavoisier would know what tricks this azote is capable of, being in the core of our sun would take his words back. But in order for the experiment to become really interesting, it's important not to be greedy and use a lot of nitrogen. After all, 1 gallon of this lifeless azote element for the spectacle is likely to be small. In addition, the sun deserves a catalyst of more magnitude. For example, with a mass equal to the total mass of all the planets of the solar system. Or even more, let's make our nitrogen heavier than several Jupiter masses. After all, this is the heaviest of all the planets of our system, almost 318 times heavier than the Earth. And don't worry, such an amount of nitrogen is not very expensive. After all, this element makes up as much as 78% of our air in the total number of gases in its composition. But even if our reserves aren't enough, you can always borrow from Uranus or Neptune. What is really worth worrying about is what happens when so much nitrogen lands in the very heart of the sun. Scientists are convinced that such an experiment could be the last in the history of mankind. After all, the temperature of the solar core is 15 million Kelvin. Because of this heat, liquid nitrogen won't just turn into gas, but it will expand at least 700 times. The pressure inside the sun will be tremendous. A little more and the star will burst into thousands of fragments. Probably, after all, according to scientists, the forces of gravity will still keep her from exploding. But now nothing can save life on Earth, and that's why. The sun is almost 80% hydrogen. Together with nitrogen, it forms explosive ammonia. Because of this, the temperature of thermonuclear reactions inside the sun will increase. Add to this the energy that nitrogen will release when it's converted to gas, and we get a phenomenon that resembles the burning of meteors in the Earth's atmosphere. We will not see this storm right away. Only 8 minutes, it's exactly how long light needs to overcome the distance from the sun to the Earth. Through these 480 seconds on our planet, the radiation of heat and light, as well as radiation, will intensify. You will have to forget about walking around during the day because the air temperature will reach 50 degrees Celsius, or 122 degrees Fahrenheit. But even if you don't go beyond your bedroom, it's likely that your skin and eyesight will suffer from radiation. All this will be accompanied by melting glaciers and deadly hurricanes with snow, which will easily demolish light buildings and trees. Hurricane snow will be replaced by warm showers and thunderstorms. Tropical vegetation will have no chance of survival, and along with it, millions of people who are doomed to starvation will die. Moreover, due to the increase in temperature, water evaporation will also increase. Relief will come only with the clouds. They will reduce the flow of solar radiation. But this joy will be short-lived. Steam-saturated air will be difficult to breathe and deadly for people with weak lungs and hearts. In such conditions, only single-celled creatures, some marine inhabitants, and primitive plants can survive. But don't think that this hot experiment will bring destruction only to humanity. The sun, due to fusion, will increase in mass and will shine stronger, and this will greatly shorten the life of our star itself. Yes, we really did go much further than the scientists from Brookhaven with their quark gluon plasma. But the difference between our experiments is that the fantasy about nitrogen inside the solar core is simply completely unrealizable. First of all, our imaginary nitrogen carrier would burn up on its way to sun. None of the materials available to human beings would allow for this transport carrier to withstand the sun's temperatures. That is, we simply can't deliver nitrogen to the sun. But even if we assume that such material could be found, flying to the center of the solar system would still remain a problem. After all, the correct orientation of the rocket would bring down a strong light pressure. In addition, the distance to the sun is about 3 times the distance to Mars. This means that the rocket would have to spend 55 times more energy to fly to the sun than to the red planet. And as you can imagine, humanity doesn't have such capacities. Not yet, anyway. Surely, after looking at this, several questions have popped into your head. What was it all about? What the hell have I just watched? Liquid nitrogen in the sun? Seriously? Who would have thought of such a crazy idea? But in fact, sometimes crazy ideas can not only entertain but even solve many problems. For example, a mad scientist relatively recently came up with this idea. What if we filled the reservoir in Los Angeles with plastic balls? Moreover, they realized their venture in reality. As a result, the balls saved the water from overheating, creating a shadow, and the reservoir eventually cleared. These crazy scientists not only caught attention from their experiment, but also received thanks from the locals. So don't be afraid to dream and ask the craziest questions. no matter how strange they may seem. If you liked the video, put your thumbs up and subscribe to the channel if you haven't already done so. And don't forget to click on the bell to enable notifications on the release of new videos. Stay with us. There's still a lot of interesting videos ahead. And don't forget to recommend us to your friends. Riddles a lot more fun together.